Okay, a few more statistical concepts that I want to introduce in order to prepare us for the deeper discussion are on the board right now. First, operationalization. Now, very often we want to study something out in the world that we have to in some way define so that we can measure it. For example, let's say that I want to study deviant sexual interest. You could operationalize deviant sexual interest in a variety of ways. You could say, I will classify someone as having deviant sexual interest if they have ever been arrested and convicted of a sex offense. Or you could operationalize deviant sexual interest by a score being over a certain point on a measure of that, such as the penile plethysmograph or the Able sexual inventory. Or you could define deviant sexual interest as the person acknowledging on a questionnaire that they fantasize about the things that we would consider deviant. So I hope it's clear that one element of doing good research is operationalizing your concept in such a way that you can measure it and in a way that makes sense. For example, if you were to ask potential sex offenders if they have deviant sexual interest, there is a good chance that they'll say, no, I don't. And then if you proceed with your experiment based on their self-report, you might find things that are actually not the case. And it's because you didn't correctly operationalize your concept. The next thing I want to talk about is that when you observe something, that observation that you're making consists of two elements. Your observed X score in this formula is combined with the true score that the person should actually have plus some amount of error. Let's take the example of somebody doing a comp exam, okay? And they're taking the comprehensive exam, and the question is, well, what is their observed score? That's easy, that's their score that they got on the test. But if we're asking ourselves, what should they truly have gotten given their actual understanding, we know that X does not equal T, because there's always going to be error when you observe something. Let's just give an example. Let's say that while you're taking the comp exam, the person next to you starts crying, okay? And you find their weeping distracting, and you answer a question that ordinarily you would have answered correctly, you answer it incorrectly because you're preoccupied with your peer who's crying next to you. That would be an example of error added to your observed score. And I hope it's clear that there's going to be error in every observation that we make. It will not always be the result of the true underlying reality of that person. Error can also be divided further into random error and systematic error. Now, an example of systematic error is a scale that is off by 2 pounds. Everyone who gets on that scale weighs 2 pounds less, according to that scale, than they actually weigh. So do you guys see that that would be systematic? Every single person weighs 2 pounds less according to that scale. An example of random error in the same experiment would be something like the amount of water that the person drank before they got on the scale, because that wouldn't be held constant, and that element of how much somebody weighs fluctuates. That would be an example of random error. And so I hope what you're understanding from this is that as much as possible we try to control for systematic error. particularly when it's having a big impact on our observed values. Random error is much harder to control for, and it's not realistic to think that you're ever going to have x equal t. X will always equal t plus e. And one of the elements of doing a good statistical analysis is saying, even though we recognize that there's error, we also believe that there are true differences based on our observed scores and the variation amongst our observed scores. And we're going to talk about that more later, but I'm just introducing those concepts now.